and welcome to Flash Forward. I'm Rose, and I'm your host. Flash Forward is a show about the future. Every episode, we take on a specific possible or not so possible future scenario. We always start with a little field trip to the future to check out what's going on, and then we teleport back to today to talk to experts about how that world we just heard might really go down. Got it? Great. This episode, we're starting in the year 2155. Welcome to the Intergalactic Travel Bureau. I'm Jana. I'll be your travel agent.
Rose, nice to meet you.
So what do you like to do on vacation?
I like to scuba dive.
Okay. We have some excellent scuba diving locales. If you would like to travel to Jupiter, there's an excellent moon there called Europa, and there's scuba diving there. It has a layer of ice that's, 20 kilometers thick or even thicker, and you can drill down through and go scuba diving down there, and everybody's always looking for life down there, and we won't guarantee anything, but you can try for it. Anything else you like to do?
I like to snowboard.
Excellent. So have you ever gone low gravity snowboarding?
No.
Okay, so it's a very different experience. The thing is you're not going to be snowboarding on regular ice. You might want to snowboard on nitrogen ice on Pluto, for example, and it's 1/10 Earth's gravity. So it takes a little while to get up speed, but the nice thing is there's very little atmosphere, so you can really get up the speed as long as you're willing to wait that out and keep going down the mountains. So I'd recommend the Hillary Mountains on Pluto for skiing and snowboarding.
I hear there's also really good sandboarding on Mercury.
Oh,
as
yeah.
well,
A lot of people don't think about that.
Yeah. There's good sands on Mercury to snowboard down or ski. The challenge with Mercury is the sun, of course. It's very close to the sun. The sun will fry you instantly if you're caught outside during the day. So I hope that you enjoy night snowboarding.
A beautiful view of the stars, but you're definitely going to need to stay on the night side if you prefer staying alive.
I do.
It's risky out there. To take a space vacation.
We definitely don't guarantee that you'll come back alive, but we'll do our best.
And it's totally worth it.
So this future is one in which we can travel as tourists to other planets. There's a lot to talk about when it comes to intergalactic travel. So in this episode, I'm going to focus specifically on tourism, not colonization, not research, not any of the other things that you could potentially try to do out in space. And we're also going to focus on a single planet, just because trying to cover all of the planets would be really hard and would take a really long time. So what would it be like to take a vacation to Mars? Just a trip for fun. Excellent. Well, we have a great location for hiking. It's Mars. It turns out that our travel agents from the top of the show are actually real space travel agents. Sort of.
I'm Olivia Koski.
And I'm Jana. Olivia and Jana are the authors of a book called Vacation Guide to the Solar System, which comes out today, the day that this podcast airs, June 6th. The book takes you through your possible tourism options for all the planets in our solar system. And it's a really delightful way to learn a lot of cool stuff about the planets. The book is an offshoot of this project that Olivia and Jana came up with years ago called the Intergalactic Travel Bureau, which is a place where people could really come inside and ask about trips to other planets. Yeah, so people would come in and we'd talk to them about what they like to do on vacation and what their favorite vacations in the past were, and then we just adapt that to the solar system and talk to them about moons and planets that they might like to visit.
So if they were more interested in warm locales, we would talk about going to the inner solar system to planets such as Mercury, Venus. If they preferred skiing or more Arctic locations, we could plan trips to Pluto, Uranus, Neptune, places like that in the outer solar system.
If they like beaches, we send them to Titan because it has methane and ethane beaches, which are 300 degrees below zero, but... And they actually set up physical locations for the Intergalactic Travel Bureau, so people could come in and get travel advice like we heard at the top of the show.
And we always provide postcards from space, so people can send a postcard from the moon, Mars, Pluto, Saturn, anywhere that they would like to go or would like to go in their minds.
Yeah, so usually people will write out the postcard as if they're writing it from the place, and we won't tell anyone that they didn't actually visit Mars.
I've been to a couple of these, and they are very cool. So if there is an Intergalactic Travel Bureau pop-up near you, you should definitely check it out. I actually still have the postcards that I got hanging up on my wall. And apparently, one of the most popular places that people want to go when they go into the Intergalactic Travel Bureau is Mars, which isn't all that surprising, right? Humans have had a special love of Mars for a long time.
The world of science fiction and just science generally, people have always been connected to Mars. And I think it's because it's close. You can see it. It's always there. It's very red. It's obviously different than the other planets. Like, it moves across the sky in the same pattern on the ecliptic, but it looks different. And you can tell that just by yourself. Like, you don't have to use a telescope to see that. You can just look at the sky and Mars stands out. Like, it looks different because it's red. And it also moves backward, or it appears to, because of the way that it orbits the sun. It has retrograde orbit. So, like, sometimes from Earth, it'll appear to go the wrong way, which is also a reason why Mars has always been, like, linked to, omens or bad histories or, religious myths. But yeah, it's sort of this, like, charismatic planet.
This is Rebecca Boyle, a science journalist who writes about astronomy for places like The Atlantic, 538, and Wired magazine. And Mars is her favorite planet.
The overarching reason is because I feel like it's kind of the Earth's little brother. It's very similar to Earth in many ways, but different enough in the only ways that matter, which is that, life may never have arisen there. If it did, it's been gone a very long time. It had a lot of water at one point. It probably had oceans. It definitely had rivers, but they're gone. It had a magnetic field at some point that's now gone. Like, all the things that it used to share in common with Earth still has, and Mars has lost. And so it's like the Earth in negative, or it's the Earth in some dystopian future. Or really, it's the Earth in its past, too. Like, that's one thing that's cool about Mars. It's like a time capsule for the early Earth.
So let's say we wanted to go to Mars on vacation. First, we'd obviously have to get there, which would actually take a long time. Traveling to Mars takes at least 6 months if you time your takeoff properly.
That's why, like, spacecraft go to Mars every 2 years, roughly. Like, they line them up because when the planets are closer together, it's a lot easier to get a spacecraft to Mars. But then it still takes like 6 to 9 months to get there, depending on how quickly you're going.
And if you're going to spend 6 months getting somewhere, you probably want to stay for more than a couple of days.
Yeah, you wouldn't want to just, like, step out, look around, take a picture and get back on the spacecraft. That would suck. Like, you'd want to be there and do stuff.
But if you stay too long, you wind up missing the window to have a quick trip back.
You either stay for just long enough that you still get to take advantage of that window, or you stay for, like, a long time, like a year, because you're waiting then for Earth to come back closer and make your journey home shorter.
So if you're going to Mars, you're probably signing up for about a 2-year trip. That's no longer really a vacation, right? I mean, I don't think my boss would be okay with me being like, hey, so I'm going to be out starting next week for 2 years. Don't worry, I'll put up an out-of-office reply. So in order for this whole vacation thing to work, I think we might need to get to Mars a little bit faster, which is really hard to do. And to find out more about that, I called Ben Longmire.
My name is Ben Longmire, and I was formerly a professor at the University of Michigan working on advanced plasma propulsion for spacecraft travel and for pushing satellites around space.
Rocket science is obviously complicated, but the basic gist of getting a rocket into space is still a giant explosion.
Yeah, so the way that rockets work now, you burn 2 chemicals. Those chemicals release some energy exothermically. You see it as fire. Hot gases rush out through a nozzle. That nozzle pushes back on the rocket, and the rocket lifts off from the ground, and there you go. You get into space.
Once the rocket gets into space, there are a couple of options for keeping it going.
Once you're in space, then there's an open question. Do you continue to use chemical rockets, chemical boosters, with this finite burn temperature, Or do you switch over to something like a ion thruster, and these have a few names, ion propulsion systems, Hall thrusters, plasma thrusters, and so on.
Ben's work was on plasma thrusters.
But the idea is, instead of burning some chemicals, you can create a plasma, which is just a collection of ions and electrons, and then you can heat that plasma and you can accelerate it out the back. And there's no limit to how much you can accelerate and heat that plasma.
One of the main advantages to using plasma is that it's a lot more efficient.
Plasma propulsion has the advantage of using a smaller amount of propellant, but it's leaving the rocket at a very high velocity, something like 10 times the velocity as a chemical thruster. So the benefit is you use a tiny amount of propellant and you use it very efficiently. So it's like the Prius of thrusters.
And it can shorten the time frame a little bit.
You can get on a faster trajectory. So you can still keep the total trip time to something like perhaps 4 months.
But that still doesn't really solve our issue of vacation timing. 4 months to get there, 4 months to get back, and sometime on Mars. That's still probably at least a year, all told. And Ben doesn't think we're going to get all that much faster anytime soon.
Getting to Mars in a month is really tough. I don't think we're going to be doing that in the next century. You just need too much energy. Forget the propellant, forget chemical propellant or plasma propellant. You just need too much energy. And I can't think of a system that, would give you that much energy unless you have a massive, massive fission rocket. But things just don't quite work out for a month-long trip.
Fission rockets are basically rockets with a controlled nuclear reaction propelling them. They work, but they're really hard to convince people to actually use, considering how afraid many people are of nuclear reactors. I mean, would you get onto a spaceship powered by a nuke?
But from the technical side, there is no better use of nuclear energy than using it in space. It basically lasts forever. It lasts for the whole duration of the mission, many decades, and the energy density is just really, really high. So from an engineer's or physicist perspective, it is a fantastic idea. It's just a difficult political sell to launch a fission reactor on a rocket where there's a 1% chance that thing's gonna explode in midair and send fragments all over the ground. That's a difficult sell, I think.
But Ben actually doesn't think that this point about it not really being a viable vacation for most people is going to really deter the people who will be able to afford this kind of trip anyway.
I think we think about tourism now as, okay, I'm going to hop on this jet plane. It's going to get me literally anywhere in the world within 24 hours. And, I'll stay there for a few days or a week and I'll come back. But if you think about how tourism was done, 1700s and 1800s, if you wanted to visit a different continent, you'd take a 2-month-long journey. You'd get to some destination. You'd stay there for several months, and you'd take the 2 or 4 month journey back. I think in that kind of context, you can consider Mars tourism. But it's still a journey that's going to carry with it, something like a 1% chance of blowing up when you take off from Earth and a 1% chance of blowing up when you take off from Mars. It's going to be a hazardous journey. And people signing up for this will just have the understanding that, okay, this, 2% of dying, I'm willing to take that risk to go.
It probably goes without saying that a vacation to Mars would be wildly expensive, something only really, really wealthy people can access for a long time. Which means that really maybe it doesn't matter after all if they take a year or 2 off to go see the sights and come back. When you're rich enough to afford a Mars vacation, you're probably rich enough to take 2 years off from whatever your job is. So let's say that you are one of those super rich people and you've boarded your ship for your Mars vacation. You're going to be on that ship for up to 6 months. And you've probably paid a lot of money for it, which means that the ship isn't going to be some kind of bare bones thing.
Right. And that's one of the things that Elon Musk talks about, his whole plan to get people to Mars, thousands of people to Mars in the next few decades, is he keeps saying, it'll be really fun. The BFR, the BFS, big fucking spaceship, will be, awesome. It'll have a pizza parlor. It'll have, a food court. It'll have, a room that you can, float in and see the views. And otherwise, people aren't going to want to go. And that may be true, but it's also not really practical in terms of like cargo space, and the little artistic renderings of Musk's spacecraft look nothing like what spacecraft has ever looked like in the history of human spaceflight.
Let's just hope that nobody on your space cruise ship comes down with any of the horrible diseases that some people get on ocean cruise ships. Then, after 6 months of travel on this giant space cruise ship, you get to Mars. And you have to land, which is really, really hard.
It is. I mean, it's ridiculous. It's super, super difficult. And so far, all we can really get to Mars is about a metric ton. That's how big Curiosity is. And so that's big. It's the size of a car. I mean, it's not small, but if you're thinking about what you need to send with you for people to be there, it's like an order of magnitude or 2 orders of magnitude more than that. And Curiosity was this ridiculous sky crane hovercraft thing. Like took so much engineering and ingenuity to get it there safely that like there's really not a plan for how to get more than that.
But let's say you land your megaship on Mars successfully. Now you're here, and it's time for phase 2 of your vacation to really begin. And when we get back, we're going to talk about what you might actually do on a Mars vacation and what might throw a wrench into your fun. But first, a word from our sponsors. Okay, so our giant space cruise ship has landed on Mars, and now your Martian vacation really begins.
You'd definitely have a lot of interesting rock climbing.
Have you been low gravity hiking before? No. So this is going to be at 1/3 Earth gravity, but you are going to need to wear a suit, obviously, to protect you from the temperatures and also keep you in breathable air. And so you might find it a little bit cumbersome, but it's going to be mostly easy hiking. I'd recommend you start out with a trip to Olympus Mons, which is, it's not an active volcano, but it is a volcano. And it's got a nice, easy slope on it, so you can kind of go and, it's not too arduous to climb up it. And you'll want to visit the caldera, which is the kind of the depression, the dip at the top of the volcano, and get a lovely view.
You would probably have like sand skiing or some kind of like dune surfing activity, because there's a lot of very soft, slippery sand that would be kind of fun to like snowboard on. I don't know if you'd call it snowboarding because it wouldn't really be snow.
Another must-see site on Mars is Mariner Valley. Mariner Valley stretches the length of the United States, and it's 4 times deeper than our own Grand Canyon. So it's pretty hard to miss. You'll be able to see it from orbit, and it's an excellent canyon to explore if you're interested in hiking and incredible views.
Yeah, really great vistas. The visibility can get low if there's a lot of dust in the air, but when there isn't, there's less atmosphere that you're looking through, and so you can really get really stunning views.
So if you're interested in a day trip, we recommend going to Mars's 2 moons,
Phobos and Deimos, and so you can jump on Phobos higher than Earth's highest building. You could jump over it if it were located there, and it would take you a while to come down, so maybe it would be boring to actually do. I don't know, but I think it'd be fun. I don't know.
You could probably golf would be really fun there, because you'd be able to hit a golf ball like super far.
And Deimos, I like Deimos because I imagine that everybody brings a baseball to Deimos and throws it into orbit, and that there's just like a bunch of baseballs orbiting around Deimos, and it's really hard to land on it because you have to go through the sea of baseballs that people have thrown into orbit. That's my vision.
Maybe you'd also go visit some relics, like the Mars Curiosity rover when it finally shuts down, or any of the other probes that we've crashed into Mars.
There's this great comic and it's like somebody coming to the remains of I think it's the Curiosity rover, and it's like future astronauts making this pilgrimage to it, and it's still there, and it's like this park where people leave things, and I imagine, who's going to move it? Who's going to throw it away, right? I imagine that people that travel to Mars will go there and see it.
This all sounds really fun. But there will also be some things that are, let's say, annoying, like the dust storms.
It's a dust storm like you've never seen on Earth, like the worst dust storm you can imagine in the Sahara, or, maybe like Arizona or somewhere that has these thousands of feet high clouds of dust like blocking out the sun. But on Mars, it can be the entire planet at some times of year. And this is not really well understood, like why these things start and stop.
If you've read the book The Martian or seen the movie, you probably remember the scene where a dust storm throws somebody around. That's not exactly what would happen. Because there's very little air pressure on Mars, the dust wouldn't actually move you that much.
There is one myth that we would like to clear up about Mars. So a lot of people are concerned about the dust storms of Mars. And I think this has been a result of movies like The Martian, which, was a good movie. But one thing that it depicted was these dangerous dust storms of Mars. And while Mars is incredibly dusty, the dust storms are not actually that dangerous.
Yeah, so the atmosphere is only like 1% as thick as Earth's. And so when you have things blowing around, they can get up speed, but you're not going to be like blown over by these winds very easily. And so it would have to be a really extreme storm to be something like what they saw in The Martian. I mean, more likely you're going to have trouble with like the seals. I guess they can't make a movie about like the seals not like like sealing properly because the dust gets in there, and then I guess that's not dramatic enough, but I think that would be like more likely what you're dealing with.
Yeah, that's going to be one of the huge problems. Like, I mean, radiation is probably the number one health hazard, and dust is probably the number two, or even equivalently dangerous. Like, you'd be inhaling it potentially because, you're coming in through your airlock or whatever, and then you take off your spacesuit. But this dust is so fine that it would just be airborne, and you would be inhaling it, and eventually that would cause a lot of problems. Could make it difficult for you to breathe. You'd have, like, asthma on Mars. Like, it would be really hard, if not impossible, to totally eliminate that from the living environment.
Yeah, I really agree with that. I think dust is sort of an underrated problem. People get freaked about radiation because it sounds scary. But so I'm still good friends with Jack Schmidt, who flew on Apollo 17. He was the last man to step out onto the moon. He and Gene Cernan were on the moon. And, just looking back at some of the photos, and they of course were on the surface of the moon longer than anyone else. And if you look at the photos of them coming back in the capsule after a couple of EVAs, they're freaking dusty. They're just sort of covered head to toe with, this fine black powder. And they were not really able to solve it.
Plus, while you're dealing with all of this dust, you're also dealing with some pretty extreme jet lag. The day on Mars is 24 hours and 40 minutes long.
So you move forward 40 minutes every day, and this adds up quickly. Like, it doesn't sound that bad because you're like, well, it's only like a little bit of time. But very quickly, it's like, 2 a.m. on Earth when it's the middle of the day on Mars. Yeah, it's basically like you're constantly flying west, and like you can't catch up.
And some people living on Earth right now actually know what it's like to live on Mars time and how awful that can be.
It's pretty bad. Like, from everything I've talked to, the people who do it really hate it. So when spacecraft get to Mars, people who work on the spacecraft go to Mars time for like 3 months, I think that's the standard at NASA. So that you're like working when the spacecraft is working. So people are getting there at JPL at like 2 a.m.
In 2012, when the Mars Curiosity rover successfully touched down on the red planet, a whole team at NASA made the switch to Mars time. And one of the engineers on that team, a guy named David O, actually had his whole family go with him. David's wife and their 3 kids all lived on Mars time for a month.
And it was like the kids weren't in school, so they could handle it a little better. And it was like they kind of looked at it as an adventure. So they'd all get up, at 2 a.m. and he would go to work, and like they would do stuff. But then the mom even said, like, well, there was nothing open, so we really couldn't do anything. And it's dark outside, so it's not always safe to play outside in the dark. So it kind of limited how much they could even really do that.
Since the trip to Mars would take 6 months, you'd probably get acclimated to the time change slowly, and maybe you wouldn't even notice it. But it would have to be part of the schedule on your Mars cruise. And it's possible that even with a slow change to Mars time, human bodies still couldn't quite adapt. We just don't know.
No one really knows what would happen in your brain over a long period of time.
Lots of people seem totally willing to sign up for a trip to Mars, whether it's a luxury vacation or a more bare-bones experimental mission. And the first trips, of course, won't be luxury space cruises. They'll actually probably be flyby missions, where instead of landing on Mars, you simply fly past it and wave. Which I have to say, to be honest, sounds horrible.
I think that route may exist, though. For one, it's going to be a lot cheaper because, people often have this idea that, oh my gosh, you're so close, let's just hop down and land. But, when you look at the physics and engineering, it's like, well, actually, no. Even though you're close, it's still 10 times harder to land than to just fly by, just from the amount of propellant you use and difficulty. So honestly, I think that'll be an option.
No, I'm sorry. I don't care how good the spaceship is. If I travel for 6 months to go see Mars, I don't want to just fly by it. I want to actually get off the spaceship.
Yeah. But I think, I totally agree. Like, psychologically, of course, you want to land, just as a person, like, oh my God, I took this travel all the way here and took all the risks getting here. Why not just sit down? But I think there will be an option. I think flybys from the beginning will be easier to do. And, there may be some wealthy older person that doesn't have time to wait, another 5 years before the landing technology really gets all of the kinks worked out. So they do the flyby.
I do wonder if the Intergalactic Travel Bureau could ever get travel insurance.
Yeah, you'd never be able to get like a liability policy if you were a Mars tourism company. Like, no one would insure you.
The reality of space travel is incredibly daunting. Like, it's not an easy thing. You're not just going to pack a bag and go to Mars. It's hugely complicated. We don't know if we can get you back alive. We don't know what's going to happen. You might not be able to survive the radiation.
This is something that we love to do, and kind of a fun tension that Jana and I have, because she is an astrophysicist. Like, she's very tied to the science behind these
I'm the
vacations. Jana,
and you're the dreamer.
Jana's a skeptic. I'm the dreamer.
And I think it's kind of fun to be flippant about it and like nod to the fact that, that it's fun to imagine these things, but the actual science of keeping people alive in space is very difficult.
Yeah, I think we've never appreciated Earth more than when thinking about traveling to other places, because we see how harsh the conditions are on other worlds.
I don't know. I think it's fun to kind of frame it in, I'm going to like take a road trip to Iowa, and no one takes a road trip to Iowa, but I'm going to take a road trip and it's going to be this easy thing, and it's going to be just like vacationing on Earth. And the Earth is where we, evolved to survive, and it brings out like how, suited we are for this environment and how unsuited we are for space travel.
That's all for this future. Flash Forward is produced by me, Rose Eveleth. The intro music is by Asura, and the outro music is by Hassalonia. The episode art is by Matt Lubchansky. Special thanks this week to Jana Gersovich and Olivia Koski. Go check out their book. It's really fun. If you want to suggest a future that we should take on, you can send us a note on Twitter, Facebook, or by email at info@flashforwardpod.com. I love hearing your ideas. I really do, and I try to respond to every email individually. It just sometimes takes me a little while, but I do really try. And if you think you've spotted one of the little references that I've hidden in this episode, you can email me there too. If you're right, I will send you something cool. If you want to support the show, there are a few ways you can do that. We have a Patreon page where you can donate. We also have a support page on flashforwardpod.com where you can see other ways to give money. But if money is not something you can give and you want to help the show, you can head to iTunes and leave us a nice review. Or just tell your friends about us. That really does help. I say it every episode, but it actually makes a huge difference. That's all for this future. Come back next month and we'll travel to a new one.